Hi guys. We're going to continue with the concept of raising a power to a power with our parentheses and our exponent on the outside. This time I'm going to put more stuff inside the parentheses. So let's think about this problem. It's very similar to the one we did earlier, except for this time I have two things inside my parentheses. I have an A and a B. So just like our previous video, I'm going to take my parentheses, and since the whole parentheses is to the third power, I'm going to write it out 3 times. So a squared b, and then a squared b, and then a squared b. And based on yesterday's rule that we learned, I can take my a's and do 2 plus 2 plus 2. And for my b's, technically they each have a 1, so that's 1 plus 1 plus 1. And my answer is a to the 6th and b to the 3rd. Based on this answer and what the original question looked like, I hope that you can see that we took that 3, which was an exponent, and we distributed it to each base. So the A got a 3 as the exponent, and the B got a 3 as the exponent. Here's the generic rule. And this doesn't have to be 2 things. It could be 3 or 4 or 10, right? It gets distributed to everything. Remember, the blue sentence and the pink equation are the most important things to take away from this video. Now, this original example was a little bit more complicated than the pink equation is. So while we did distribute the 3 to every base, if a base already has an exponent, you need to multiply with the pre-existing exponent. So like the A already had an exponent of 2. So when I distribute the 3 to that, I'm going to multiply it with the 2 that was already there. And then since the B did not have an exponent written down, I could just give it an exponent of 3. Let's practice this a little bit more. So here's another example. In this problem, I have 3y to the 5 halves, and then that entire thing is being raised to the power of -2. My first step on this problem is to identify my bases. Now, a base is anything that is written normal sized. So I'm pretty sure we all realize that y is a base, but 3 is also a base. So if there is a number inside the parentheses, you do need to distribute your exponent to the number as well. So I will be distributing the -2 to the y and also to the 3. When I give the -2 to the 3, I need to keep the -2 and exponent written above the 3. So I don't want to make them the same size. It's not 3 times -2. It's 3 to the power of -2. So just make sure that your exponents always stay exponents. Since the y already had an exponent, I will be multiplying the -2 with the pre-existing exponent. And in this problem, my 2's will cross cancel, leaving me with a -5 for my exponent on my y. Now, based on the directions, I do want to simplify this as much as humanly possible. So I am not done with this problem. You cannot have a final answer that has a negative exponent. So the next thing I'm going to do is I'm going to identify any base with a negative exponent, and I'm going to shift it to the bottom of the fraction. In this problem, both of my bases have negative exponents, so I'm going to put the 3 and the y underneath the fraction bar. Since there's nothing else left for the top of the fraction, I'm going to put a placeholder of 1 so that it does stay a fraction. And then notice that all of my exponents turned into positive numbers when I put them below the fraction bar. As my one final step of simplifying, I do actually know what 3 squared is. 3 squared is 9, so I do want to change that to the number 9. And this pink fraction is my final answer. Before you try your homework, I'd like you to try these 2 problems on your own so that we can check our answers on the video. Make sure to pause the video, do the work on your paper, and then unpause once you have your answers ready to check. Hopefully you already wrote down your answers because I'm only putting final answers. So the final answer for number 1 is 343, x to the 27th, y to the 3rd, and z to the 9th. And then the final answer for question 2 is 1 over 16z to the 16th. This concludes our second video.